Hi students. In this lecture, I am going to discuss problems based on law of conservation of angular momentum. Let us see first one. Let's see the question given. A horizontal circular plate is rotating about a vertical axis passing through its center with an angular velocity omega naught. A man sitting at the center having two blocks in his hands so that the moment of inertia of the system doubles. The kinetic energy of the system is K initially. Its final kinetic energy will be. So here key point is when man sitting at the center having two blocks, moment of inertia of the system doubles. So we have learned that I omega equal to I omega is a constant, right? So when I value is doubled, omega becomes a half. So he's asking about kinetic energy. Let us see. Let's see the condition given. In this, on the system, net torque equal to 0. That means I omega is a constant. And given that I2 is half of I1, right? Wait. It is a double, right? Not half. It doubles. Given that I value is doubled. It is 2 times of I1. See now what we can write. Since he's asking about kinetic energy K equal to half pi omega square, or we can write this as, so we are knowing L equal to I omega. In terms of L, this can be written as L square by 2I. You can just compare with a half mv square. It is a half I omega square. It is just like P square by 2m. It is L square by 2I. Now in this, L is a constant. I value is now doubled. So from this we can write, since L is a constant, K into Y is a constant, right? Now since I value is doubled, kinetic energy becomes a half, okay? So very simple and direct one. So answer is option B. It becomes half, okay? Let us see next one. A thin circular ring of mass caplum, radius small r, is rotating about its axis with a constant angular velocity omega. Two objects, each of mass smaller, are attached gently to the opposite ends of a diameter of the ring. The wheel now rotates with an angular velocity. Initially, it was only ring, now attaching two objects at the ends of a diameter. So what happens to omega value? So again writing I1 omega 1 is equal to I2 omega 2. So writing I1 omega 1 is equal to I2 omega 2. In the place of I1, we can write, since it is a ring, mr square into omega, that is equal to, now it is mr square, that is for ring. Next, for particles, or you can say two objects, mr square, because we are placing at the ends of diameter, right? At the ends of diameter. So their distance from center equal to r. So m r square for one object, for two objects into 2. I into omega dash. That means omega dash is equal to m omega upon m plus 2m, right? So it is also a very simple question. So m omega by m plus 2m. That means option is, it is a C, right? See next one. A circular platform is free to rotate in a horizontal plane about a vertical axis passing through its center. Given circular platform, or we can take it as a disk, a tortoise is sitting at the edge of the platform. Now, the platform is given an angular velocity omega naught. When the tortoise moves along a chord of the platform with a constant velocity with respect to the platform, the angular velocity of the platform will vary with the time as. So we have to get relation, right, for omega as a function of time. Let us see how to start the problem. So first make a diagram for the given data. So it is given that a tortoise is moving along a chord. So take a chord here. So it is moving along the chord. The tortoise is moving along the chord with a constant velocity relative to the disk, right? Now see what happens. So when this is moving like this, moment of inertia of the system is changing. We can see I omega is constant. So now in this, when tortoise is moving along the chord, we just observe its a distance, how it is changing from the axis. This is now axis, means normal to the plane. Or you can say, if this is now in the board plane, axis is now normal to the board and horizontal. So when tortoise is moving, its distance from the axis is decreasing until it reaches the midpoint of the curve, right? Until tortoise reaches the midpoint of the curve, its distance decreases. And after that, distance increases. Okay. That means initially I value for system is decreasing. So when it is decreasing, omega will increase until tortoise reaches center of the chord. And after that, again distance increases. That means I value will increase, then omega will decrease. Okay. And in this we can say this variation is not linear. It is non-linear. That is what we can guess. Okay. Otherwise, we can say like this. For the disk, I value mr square for the disk. For tortoise, suppose distance is now, take it as this is x distance. Then it is mx square, right, into omega. That is equal to initially how much? Mr square plus mr square. When it was at one end of the chord, distance equal to r. Okay. into initial value omega naught. This is a constant. Coming to here omega equal to that constant value upon it is mr square plus mx square. So from this we can say this is a constant by this value. In this x is variable. It is now x square. So we can say that omega is not changing linearly, right? Then say options. It is not changing linearly. So option A is not correct. Option D also not correct. Okay. Now remaining is only option B, because in option B, omega increasing then decreasing. So just now we have seen that distance of the tortoise from the axis of rotation is decreasing. That means I value is decreasing, right? I value decreasing means omega value is increasing. After reaching midpoint of the chord, I value becomes minimum. So omega becomes maximum. And after that, when it continues to move, then its distance will decrease, its distance will increase from the axis of rotation. Means I value increasing. So omega value will decrease. So option B is matching, right? And coming to option C, it is not a correct, because first omega decreasing, then omega increasing. So correct one is option B, right? Let us see next one. A uniform circular disc of mass 50 kg and radius 0.4 meter is rotating with an angular velocity 10 radian per second about its own axis. Given circular disc mass 50 kg, radius 0.4, omega 10, which is vertical. Two uniform circular rings, each of mass 0. Each of mass 6.25 kg and radius 0.2 meter are gently placed symmetrically on the disk in such a manner that they are touching each other along the axis of the disk and are horizontal. Assume that the friction is large enough such that the rings are at rest relative to the disk and the system rotates about the original axis. The new angular velocity of the system is, so asked 2013 advance. First, let us make a diagram for the given data. Then we get a clarity what is the question given. Let's say first of all given circular disk. It is circular disk rotating about its own axis. Its mass given 50 kg. Radius is given 0.4 meter. Initially omega value, take it as omega 1, that is given 10 radian per second. Okay. Now two uniform rings given mass 6.25 kg, 6.25 kg, and their radius is given 0.4, 0.2, 0.2 meter, gently placed symmetrically on the disk in such a manner that they are touching each other along the axis of the disk. So this is more important here. So how they are placed? It is given that they are placed symmetrically, touching the axis of the disk. Means The diagram will be diagram is now like this, touching along the axis, right? Means once we get this clarity, remaining is very simple. So just writing here, I1 omega 1 is equal to I2 omega 2. I1, let us take this as smaller. This is a capital R. This is smaller. See what is I1? It is a disk, right? Disk means about its own axis, m r square by 2. Omega 1, that is given. That is equal to, now about the same axis for these two, see what is moment of inertia. So this is now tangent normal to plane of the rings, right? So for a ring, about a tangent normal to plane of the ring is 2mr square. That means now the value becomes mr square by 2 plus 2mr square, okay, into omega 2. If you get this clarity, remaining is now just a calculation part. Okay, it is just substituting values in this. Check once. It is a disk given, so mr square by 2. Remaining two are rings. That's why 2mr square. So substituting values in this, then you are going to get the answer. So from this, we are going to get omega 2. That is 8 radian per second. So here major thing is writing equation, right? Then remaining just calculation part. Let us see next one. Let's see the question given. A ring of mass m and radius r rotating with angular speed omega about a fixed vertical axis passing through its center O with 2 point masses each of mass m by 8 at rest at O. These masses can move radially outwards along two massless rods fixed on the rings as shown in the figure. You can see here diagram. At some instant, the angular speed of the system is 8 omega by 9. And one of the masses is at a distance of 3r by 5 from O. At this instant, the distance of the other mass from O is, so asked in advance 2015. So again, basing on conservation of angular momentum, initial value given as omega. So now we have to find what is omega value. Sorry. Now omega value is given, right? We have to find distance of other mass. See calculation part. First of all, write down given data. It is given ring. A ring is given. Mass capillum, radius capillar. Capillar, and it is given angular velocity omega about 0.2. Now given 2 point masses, each of mass m by 8 at rest at 0.2, right? So condition is 2 point masses on the axis. That means initially moment of inertia, it is only mr square into omega. That gives angular momentum because remaining two are point masses and they are placed at rest, right? At center O. That means those 2 point masses are on the axis. So for them, moment of inertia is zero. This is initial angular momentum that is equal to, now see what he is saying here. So it is given that at some instant, the angular speed of the system 8 omega by 9. Now see what happens. I value mr square for the ring. Wait, it is mr square for the ring. Mr square for the ring. And given angular velocity 8 omega by 9. So angular momentum for the ring. Next, given 1 point mass is at a distance 3r by 8 and given mass is m by 8, mass m by 8, distance 3r by 5. This is giving us moment of inertia of that point mass into given omega value, that is 8 omega by 9 plus the other one m by 8. Suppose now distance is x, so x square. This is moment of inertia for the other point mass, right? Into 8 omega by 9. So we have taken I1 omega 1 is equal to I2 omega 2. So in this, the only unknown is now x, right? Now see how to make calculation. Root m gets cancelled, r square gets cancelled, right? Omega also gets cancelled. M r square omega. M r square omega. M. Wait. R is not cancelled, right? You have here x square. Okay. Or we can do one thing. Take here by r square. Okay. Since we have cancelled it, it is now m omega cancelled. Right. Next, see calculation. What else? Here 8 and here 8 gets cancelled. Here 8 and here it gets cancelled. This is 1. Having here 8 by 9. So minus 8 by 9. And here what else left? It is 9 by 25. 3 square 9 gets cancelled. Minus 1 by 25. Cross check once again carefully. 1 minus 8 by 9. Here 1 by 25 I have taken here. Remaining is now x square by r square by 9. X square by r square into 1 by 9. Now simplify this. See how much it is. This is 1 minus 8 by 9. That is 1 by 9. 1 by 9 minus 1 by 25. 25 minus 9, 16. 16 by 9 into 25. That is equal to x square by 9r square. 9 gets cancelled. From this, x equal to 4r by 4r by 5, right? So it is simply writing I1 omega 1 is equal to I2 omega 2 and remain just calculation part. So final answer is x equal to 4r by 5. And see options given. So it is option D, right?